When you hear the word mineral, you may think of a sparkling gem, but in fact, most minerals are found in groups that make up rocks. A mineral is a naturally occurring, usually inorganic solid that has a definite crystalline structure and chemical composition. To understand what a definite chemical composition is, you need to know a little bit about elements. Elements are pure substances that cannot be broken down into simpler substances by ordinary chemical means. Each element is made of only one kind of atom, and all substances are made of atoms. So therefore, atoms can be thought of as the building blocks of matter. And if a substance is made up of two or more elements, then the substance is called a compound. Matter is anything that has volume and mass. Volume refers to the amount of space an object takes up. For example, a golf ball has a smaller volume than a basketball does. Matter is generally found in one of three states: a solid, a liquid, and a gas. A mineral is a solid. It has a definite volume and shape. Some substances made by animals, such as a turtle shell, are categorized as inorganic. An inorganic substance is usually one that is not made up of living things or the remains of living things. However, unlike turtle shells, most of the processes that form minerals usually take place in the non-living environment. Minerals have a crystalline structure because they are composed of crystals. A crystal is a solid geometric form that results from the repeating pattern of atoms or molecules. A crystal shape is produced by the arrangement of the atoms or molecules within the crystal. This arrangement is determined by the kinds of atoms or molecules that make up the mineral and conditions under which it forms. All minerals can be placed into a crystal class according to their specific crystal shape. Many minerals grow from magma. Magma contains most of the types of atoms that are found in minerals. As magma cools, the atoms join together to form different minerals. Minerals also form as lava cools. Lava is just molten rock that's reached the Earth's surface. Temperature and pressure within the Earth cause new minerals to form as bonds between atoms break and reform with different atoms. Water usually has many substances dissolved in it. As water evaporates, these substances form into solids and come out of solution, or precipitate. Minerals can also form from hot water solutions. Hot water can dissolve more minerals than cold water. As a body of hot water cools, dissolved substances can form into minerals. The most common classification of minerals is based on chemical composition. Silicon and oxygen are the two most common elements in Earth's crust. Minerals that contain a combination of these two elements are called silicate minerals. All other minerals are called non-silicate minerals. Some of these minerals are made up of elements such as carbon, oxygen, fluorine, iron, and sulfur. The same mineral, like quartz, can come in different colors. Different minerals can also be the same color. So using color is helpful, but usually it's not the best way to identify a mineral. The color of the powdered form of a mineral is its streak. A mineral streak is found by rubbing the mineral against a white or black tile called a streak plate. The mark left is its streak. A mineral streak is not always the same as the color of the mineral, but all samples of the same mineral have the same streak color. Unlike the surface of a mineral, the streak is not affected by air or water. For this reason, streak is more reliable than color in identifying a mineral. The way a surface reflects light is called luster. When you say an object is shiny or dull, you are just describing its luster. The two major types of luster are metallic and non-metallic, but as you can see, there are many ways in describing a mineral's luster. The tendency of a mineral to split along a specific plane of weakness to form smooth, flat surfaces is called cleavage. When a mineral has cleavage, it breaks along flat surfaces that generally run parallel to planes of weakness in the crystal structure. For example, muscovite tends to split into parallel sheets. Many minerals, however, do not break along cleavage planes. Instead, they fracture or break unevenly into pieces that have curved or irregular surfaces. Scientists describe a fracture according to the appearance of the broken surface. For example, a rough surface has an irregular fracture, and a curved surface has a conchoidal fracture. Density is the measure of how much matter is in a given amount of space. The formula is mass divided by volume. To find the density, use the volume displacement method. Using a scale, find the mass of the mineral. Fill a graduated cylinder up with water to a good even number. In this case, I'm using 60 milliliters. Carefully drop the rock into the graduated cylinder filled with water. Adding the rock to the water makes the water rise to 66 milliliters. The initial volume was 60 milliliters. The water then rose to 66 milliliters after the mineral was dropped into the water. Subtract these two numbers and you get your final volume of the mineral. In this case, the volume is 6 milliliters. Now that we have the volume and the mass of the mineral, we can find the density. Rewrite your formula, mass divided by volume. Fill in the variables. Our mass was 21.7 grams, and our volume was 6 milliliters. Go ahead and use a calculator for the math. When you write your answer, go ahead and round to the nearest 100th or 2 decimal places. Be sure that you use the correct unit of measurement. In this case, it's grams per milliliter. A mineral's hardness is its resistance to being scratched. To determine the hardness of minerals, scientists use the Mohs hardness scale. Notice that talc has a hardness of 1, gypsum a rating of 2, calcite 3, fluorite 4, and so on, and diamond has a rating of 10. The greater a mineral's resistance to being scratched, the higher its hardness rating. To identify a mineral by using the Mohs scale, try to scratch the surface of a mineral with the edge of one of the 10 reference minerals. If the reference mineral scratches your mineral, the reference mineral is as hard or harder than your mineral. This will help you to determine the hardness of the mineral. In this case, our mineral has a hardness of 5.5. The mineral magnetite is a natural magnet. All minerals exhibit the properties that were described earlier in this section. However, a few minerals have some additional properties, just like magnetite. Now go identify some minerals.